Hello learners, today we are introducing a course that is Thermodynamics and its application. This course will be offered through Swayam platform. So in this course, generally we will discuss about the thermodynamics and its different properties, and today is the first class. The topic of this first class is fundamental concepts and definitions, and we are introducing the module 1. In this module we will introduce you the thermodynamics, the importance of thermodynamics, and generally we discuss about the work, energy and heat. Let us see what is the meaning of thermodynamics. Thermodynamics is the science of the relationship between heat, work and the properties of substances. Heat and work are intimately connected through energy, and hence thermodynamics is defined as the study of energy. Energy is essential and vital component of our life. Hence, knowledge of thermodynamics is also essential for all of us. Thermodynamics deals with stored energy like chemical, potential, nuclear, etc., energy fluxes, energy exchanges, and the associated changes in properties. Now, to begin our study of thermodynamics and its application, we must have in mind some definable quantity of matter which we wish to consider. Then the behavior of energy as it interacts with this matter can be examined. First of all, let us see what is energy. Energy is a property of matter that can be converted into work, heat or radiation. Energy is the essence of life, and energy is defined as the capacity to do work. So in this module, we will mainly concerned about energy and energy transfer. So let us see that what are the forms of energy. There are mechanical energy, thermal energy, electrical energy, sound energy, magnetic energy and nuclear energy. First of all, now let us discuss the unit of energy. When you think of the BTU, that is the British Thermal Unit, this is the unit of energy in FPS system. 1 BTU is the equivalent to the energy required to raise the temperature of 1 pound of water by 1 degree Fahrenheit. But in SI system of units, the unit of energy, the joule, is defined as the energy supplied by a force of 1 Newton in causing movement through a distance of 1 meter. See, what is the role of energy? We all know that energy has been universally recognized as one of the most important inputs for economic growth and human development. There is a strong two-way relationship between economic development and energy consumption. Energy is the capacity to exert a force through a distance and manifest itself in various forms. Energy in our engineering processes involve the conversion of energy from one form to another, the transfer of energy from place to place, and the storage of energy in various forms utilizing a working substance. The unit of energy in the SI system is Newton meter or joule. The energy per unit mass is the specific energy, the unit of which is joule per kg. Now let us talk about the power. We all know that the power is defined as the rate of doing work. The unit of power is watt. 1 watt is equal to 1 joule per second, equal to 1 Newton meter per second. Some bigger units of power are also available. Say for example, when you talk about 1 kilowatt, that is equal to 1000 watt. When you talk 1 megawatt, that is equal to 10 to the power 6 watt. And when you talk about 1 gigawatt, that is equal to 10 to the power 9 watt. Now, energy measurement, the units are BTUs, calories, kilowatt hour, joules, and one can be converted to another if the conversion factor is known. Now, this diagram will tell us how the energy transformation takes place. First, see on the topmost figure, that is the thermal power plant where the boiler is producing steam. But how the boiler will produce steam? Because the coal is burning inside the boiler, we get tremendous heat, and that heat is being utilized for converting water into high pressure, high temperature steam. And that steam will pass through the turbine, and the turbine shaft rotates. The shaft of the turbine is coupled with the shaft of the generator, and in turn generator will produce electricity. Here you see the conversion takes place in the boiler. When we burn coal, we are converting chemical energy to heat energy, and the high pressure, high temperature steam, that is, it is having thermal energy, and when it rotates the shaft of the turbine, that means thermal energy we are converting into kinetic energy due to the rotation of the shaft of the turbine. And when the generator is producing electricity, that kinetic energy in rotation is transforming into electrical energy. And you see the car, when the car is moving, it will get the energy. It gets energy because of the fuel. We use petrol or diesel. Here the chemical energy is converting into kinetic energy. And here some soccer player is shown, and how the soccer player is getting energy because of chemical energy is converting into the kinetic energy, or work because the food which he takes as an input, that contains chemical energy. Now, we will concentrate ourselves a very important terms like system, surroundings, and boundary. Now, a system, if it may have a fixed amount of mass or a fixed volume. Now, if the mass is confined in a system, and that is known as the closed system, or we call it control mass, and the system is surrounded by a boundary, and outside the boundary we call it surroundings. Now, system plus surroundings is known as the universe. Now, control volume, that many systems are most conveniently analyzed as a system fixed in space which permits mass to cross the boundaries. Such system is defined as to be an open system, or we can also say it is a control volume. So, if the mass is fixed and if it is confined within the boundary, we call it closed system or control mass. If the volume is fixed and inside that, we call it control volume, and in this case the mass is not fixed. Mass may enter into the control volume or leaves from the control volume to the outside. But when you think of a control volume, there is the work interactions in between systems and surrounding, heat interactions in between system and surrounding, and also mass can come into the control volume or can go out from the control volume. We will now introduce a very important system. We call it isolated systems. We have already discussed about the closed system. We have already discussed about the open system. But for an isolated system, there is no interaction permissible from the system and the surroundings. Now, this figure will also explain us what is isolated system, what is closed system, what is open system. The isolated system, there will be no interactions of energy and matter within the system. So that's why it is given as there is no exchange of energy and there is no exchange of matter in the isolated system. But in a closed system, here you see that there is no exchange of matter. So matter will not go out from the system or come into the system. The matter is constant within the system. That's why it is known as a closed system. But in open system, there may be exchange of energy and exchange of matter. So we will deal with these three types of system while analyzing any thermodynamic systems in later stage. Now, some common properties that in science you might have come across about pressure, volume, temperature. So we will discuss about those common properties. A property is any observable characteristics of a system. A property may be either directly observable or indirectly determinable. Many such quantities are familiar to us from other branches of science such as mass, energy, pressure, volume, density, electrical field and magnetic field, etc. And two other properties, that is temperature and entropy, are unique to thermodynamics. Now, classification of properties. The properties of a system may be divided into essentially two types. One is intensive properties, another one is extensive properties. Intensive properties are those which are independent of the amount of material in the system. Say pressure, temperature and density are the examples of intensive properties. But extensive properties are related to mass, volume, energy and entropy are the examples of extensive properties. Now let us define force, because this we must recapitulate about the force which you have learned in our earlier courses. The force acting on a body is defined by Newton's second law of motion. The unit of force is the Newton. A force of 1 Newton produces an acceleration of 1 meter per second square when applied to a mass of 1 kg. Now weight. The weight of a body is the force with which the body is attracted to the center of the earth. It is the product of its mass and the local gravitational acceleration. So W is equal to m into g. Now pressure. Pressure is also one of the very important thermodynamic property. Pressure is defined as the normal force exerted per unit area on a real or a fictitious surface within the system. The pressure of a system is often measured with a gauge by employing the atmospheric pressure as the datum. In such case, if the pressure is above the atmospheric, it is called gauge pressure, and if it is below atmospheric, it is called vacuum pressure. Now this diagram will tell us how to calculate the absolute pressure when it is calculated as gauge pressure. Absolute pressure is equal to atmospheric pressure plus gauge pressure, and in case of vacuum, absolute pressure is equal to atmospheric pressure minus vacuum pressure. So this diagram will give us clear picture about gauge pressures, vacuum pressure, absolute pressure and local atmospheric pressure. Now we will discuss very important terms like state, process and path. These are very important in the sense that when we discuss any thermodynamic system, we must know what is state, what is process and what is path. The condition of a system is called its state. Any operation in which one or more of the properties of a system changes is called a change of state. Now, how to calculate how do we know about the state of a system? The state of a system is defined by two independent properties for the system. Say for example, pressure and volume, pressure and temperature and temperature and volume. These are the, if these two properties are independent of the system, then we can define the state of the system. And the change of state, say for example, we are keeping some gas within the cylinder and piston, with the help of the piston, and we can compress it, but before compression the gas will be having certain pressure, certain temperature, and certain volume also. So if we compress it, the properties of the gas will change, and if we compress it and finally if we stop it, then that will become the state 2, and for the state 2 all the properties will change, like pressure, temperature and volume. So this is the examples of change of state. Now the succession of states passed through a change of state is called the path of the change of state. When the path is completely specified, the change of state is called a process. So example is constant pressure process. Now here we are discussing about the state of matter. Now you see, any matter may be in liquid form, in a gaseous form, or in solid form. Say for example, when you think of ice is a solid, but if you supply heat, it will melt. So it will transform into liquid. But again, if you apply heat, then at the temperature of the water will increase, and if you supply heat more and more, and definitely the temperature will rise up to 100 degrees centigrade and it will convert into vapor. So these are the different state of matter. So in this figure you see that when there is a liquid, when the vaporization process takes place, it will transform into vapor. And if the condensation process occurs, so it may also transform it from vapor to the liquid. And for a solid, it can transform into vapor directly. Say for example, camphor. So if you put it in open space, it will be transformed into vapor immediately. So this is the transformation from solid to vapor directly, and this process is known as sublimation. And if the reverse process takes place from vapor to solid, that process is known as depositions. Now let us talk about the thermodynamic cycle. A thermodynamic cycle is a series of thermodynamic processes which returns a system to its initial state, and properties depends only on the thermodynamic state and thus do not change over a cycle. This is a pressure volume diagram, and you see that 1 to 2 there is expansion takes place, and 2 to 3 the pressure decreases but volume remains constant. So it is known as constant volume process where pressure is decreasing. And 3 to 4 again the pressure increases and volume decreases. So it is a compression process where volume decreases and pressure increases. And 4 to 1, and this is the constant volume and a compression process where pressure increases. So this is a thermodynamic cycle, and we will discuss different thermodynamic cycle again and again while discussion in refrigeration and air conditioning systems or thermal power plant, the power generations. For all, we will discuss this thermodynamic cycle again and again. Now let us talk about the specific heat. The specific heat of a substance is defined as the amount of heat required to raise a unit mass of the substance through a unit rise in temperature. The symbol C will be used for specific heat. C is equal to Q divided by M delta T, and its unit is Joule per kgK, where Q is the amount of heat transfer, whose unit is Joule, and M is the mass of the substance, and kg and delta T is the rise in temperature, unit is Kelvin. Now, for any thermodynamic analysis, we have to have some knowledge of the function representations. So consider the functions f, x, y, z is equal to c, that is constant, which represents a surface in the three-dimensional space coordinates x, y, and z. And an alternate representation is z as a function of x and y, where the value of z is uniquely specified by the values of x and y. If you write z in terms of functions of x and y, the x and y are known as independent variables and z is dependent variable because the value of z is dependent on the value of x and y. So in thermodynamics, if you know any two properties, so we can find out the third properties by knowing some laws or equations. Now let us do some numericals so that your concept will be more clear. So whatever we have discussed, we discussed about the thermodynamic properties and we have discussed about intensive and extensive properties. Now let us see how we can solve these problems by the relations of different properties. Say a pump discharges a liquid into a drum at the rate of 0.04 meter cube per second. The drum, 1.6 meter in diameter and 4.5 meter in length, can hold 9,000 kg of the liquid. Find the density of the liquid handled by the pump and the mass flow rate of the liquid handled by the pump. So we know that density is equal to mass per volume, but mass is given as 9,000 kg, but volume is not given. But here you see that volume we can calculate from the given data for the cylinder, that is here the diameter of the drum is given as 1.6 meter and the length of the drum is given as 4.5 meter. So we know that volume of a drum is equal to pi by 4 d square into L. So d is given, L is given, we can calculate the volume, and after putting this volume in the equations of densities mass per volume, we can calculate that final value will come out to be 994.72 kg per meter cube. But if you want to calculate the mass flow rate is nothing but density into the volumetric flow rate. The density you have calculated, volumetric flow rate is given as 0.040 meter cube per second. So we can calculate mass flow rate with this formula, that is mass flow rate is equal to rho into volumetric flow rate, that is 994.72 into 0.040, that will come out to be 39.79 kg per second. So from this problem we have calculated density, we have also calculated the mass flow rate. Now the next is that classify the following properties as either intensive or extensive properties. Now we know very well that intensive properties are independent of mass, but extensive properties depends on the mass. So volume, when you think of volume, it depends on mass, so it is an extensive property. Weight is an extensive property because we have already discussed that weight W is equal to m into g. It depends on mass, so it is an extensive property. But pressure doesn't depend on the mass, so it is an extensive property. Temperature is independent of mass, it is an intensive property. And density is independent of mass, it is an intensive property. And velocity is also intensive property, elevation is also intensive property. But when you think of kinetic energy, because we all know that kinetic energy is defined as half into mass into velocity square, half mv square, so it is an extensive property. Now the next example is a bottom gauge on a steam generator. shows a pressure of 700 kilopascal. The barometer reads 755 millimeter Hg. What is the absolute pressure in kilopascal of the steam in the steam generator? Take the density of mercury to be 13,600 kg per meter cube. So here you see, first of all, we have to calculate atmospheric pressure, because we know very well that absolute pressure is equal to atmospheric pressure plus gauge pressure. Here gauge pressure is given as 700 kilopascal. So we have to calculate the atmospheric pressure, but we all know that atmospheric pressure is equal to rho into G into H. What is rho? That is the density. Here we have to take the density of the mercury, and G is the acceleration due to gravity, and H is the height. So here the barometer reads as 755 millimeter, but 755 millimeter is equivalent to 0.755 meter. So we can calculate atmospheric pressure by putting the value of density at G and H. But so one atmospheric pressure will be equal to 13,600 into 9.81 into 0.755. That is equal to 100729 Pascal. But we have to convert into kilopascal, because gauge pressure is given in terms of kilopascal. So if you want to convert it to pascal into kilopascal, we have to divide 1000. So that comes out to be 1000.73 kilopascal. So we have got the atmospheric pressure in terms of kilopascal. So if you want to calculate the atmospheric absolute pressure, and already you know the atmospheric pressure and gauge pressure, so there is no problem for calculating absolute pressure is equal to atmospheric pressure plus gauge pressure, and that will comes out to be 800.73 kilopascal. Now we have discussed about different properties. We have discussed about types of properties like intensive and extensive properties, and we have introduced the term like path and change of state and process. We have also discussed about the thermodynamic processes, and we have also defined what is thermodynamic, and we have also discussed about the closed system. We have also discussed about the open system. Closed system is also known as control mass. Open system we have discussed, and open system is also known as control volume, and we have also discussed about isolated systems. And this knowledge of the system, closed system or open system or isolated system will be very much useful for further analysis of the thermodynamic system. So let us summarize our discussions. So we have discussed we have introduced the thermodynamics, and we have introduced the properties of a system. And these properties of systems, you know very well that pressure, temperature, volume, internal energy, enthalpy, and temperature and energy, entropy. These are different thermodynamic properties, and in our next classes we will discuss about the two very important properties like energy and entropy. And we have discussed about the state, we have discussed about the change of state and processes and path and thermodynamic cycle and energy and different forms of energy. And we have also seen that we can discuss about different forms of energy like thermal energy, electrical energy, magnetic energy, nuclear energy, and we have also discussed about the power. So thank you very much for today's discussion. So in the next class we will come out with a new topic, that is energy and energy transfer. So thank you very much. So if you have any queries or any doubt, you can discuss with me through my email and or mobile and so on. Thank you very much.